Hello everyone. Our new topic is algebraic expressions, chapter number 12. And we very well know that expressions are formed using variables and constants. Actually, we take some variable and also we take some constant, and then we use some operation between these two to form an algebraic expression. Like x plus 4 here is an algebraic expression. In this, x is a variable. This number 4 is a constant. And this is the operation which we are using in between x and 4. So all this you have learned in your previous class as well. Now what we are going to do in today's session, we will learn about some very important terms which are related to algebraic expressions. First of all, terms of an expression. I'm writing an expression here. This is an algebraic expression. You can see variable x, constants 5 and 7, and operation of addition between x square, 5x and 7. Now these three are the terms of this expression. This is first term, second term, and the third term. So terms of an expression are defined by the signs of addition or subtraction. If I take two variables, a variable and a constant as x and 7, if I'm putting a sign of plus between these two, I will get two terms. Or if I put a sign of minus between these two, again I'll get two terms. But if I put a sign of multiplication between these two, suppose I'm multiplying x and 7, then this will be written as 7x, which will be treated as one term. 7 and x in this case are not two terms. They are making a single term, that is 7x is one term. So in the same way, in this given expression, there is a sign of multiplication between x and x. X into x makes x square, which is one term. Similarly here, 5 into x is making 5x, which is a single term, and 7 is a single number here, so it is also a single term. So this expression has three terms. Factors of a term. Look at this expression. This expression has two terms, 5xy and 10. Now each of these two terms can be further splitted into factors. Like this 5xy is made by multiplication of 5x and y. So I will say 5x and y are the factors of first term. In the same way, this number 10 can be written in their in its prime factors as 2 into 5. Next we have coefficients of terms. An expression is given with two terms, 2xy and 7y square are its two terms. Now, among the factors of the first term, this first term can be factorized as 2 into x into y. The numerical portion is known as the coefficient of first term. This will be the coefficient of first term. In the same way, this 7y square can be factorized as 7 into y. The number in this is known as the coefficient. So 7 is the coefficient of its second term. Like and unlike terms. When the terms have same algebraic factors, then they are said to be like terms. For example, I have written three terms with different coefficients and their variables are same with same power. In the first term which I have written here, its coefficient is 2, but the variables are x and y. So x into y is an algebraic factor here. In the same way, we can see xy here and the second one, and also in this third one. These three are the like terms. On the other hand, if the variables with their powers are not same, then we say that those terms are unlike terms. For example, 5x, 5x square, 5xy. Here in these three, the coefficients are same, but here we are given only single x. Here power of x is 2 and here x is getting multiplied with y. So these three are unlike terms. We'll say these are not like terms. And why we are doing these like and unlike terms? Because later on you will find that when we have to add the terms or we have to subtract the terms, we can do this only for the like terms. Only the like terms can be added or subtracted with each other. Unlike terms cannot be added or subtracted. Exercise 12.1, first question, first part. Some statements are given and we have to change these statements to algebraic expressions. The very first one is subtraction of z from y. We are subtracting z from y, which means the expression will be y minus z. In the same way, its third part is the number z multiplied by itself. Z is to be multiplied with itself. So z into z, which becomes z square. So your answer is z square. The fourth part of same question is 1/4 of product of numbers p and q. 1/4 of product of p and q. I'm taking two variables p and q. I'm taking their product p into q and 1/4 of it. So your answer will be 1/4 pq. Sixth part, number 5 added to 3 times the product of m and n. We have to take the product of m and n, which is mn, and 3 times of this, which means 3mn, and then number 5 is added to it, plus 5. So expression will be 3mn plus 5. Eighth part of the same question, Sum of numbers a and b subtracted from their product. A and b, this is their sum, and this thing is to be subtracted from their product. So their product is AB. Your answer will be AB minus A plus B in bracket. Exercise 12.1, second question. Its first part is identify the terms and their factors, and we have to show the terms and factors by tree diagram. Part A is this expression is given x minus 3. So the two terms will be represented as x and minus 3. Now factors of x will be x only, and factors of minus 3 will be written as minus 1 into 3. In the same way, we'll do its d part, which is 5xy square plus 7x square y. Its two terms are given by 5xy square and 7x square y. Now we will factorize these terms. Factors of the first term are 5x, y and y. 5 into x into y becomes 5xy square. In the same way, for the second term we have the factors as 7 into x into y. Its second part is again we have to identify the terms and factors. It's let us do its b part. B part is minus 4x plus 5y. So we have to find the terms and their factors. So terms are given as minus 4x and 5y. Now we will write the factors of these terms. Factors of the first term minus 4x are minus 4 and x, and for the second term the factors are 5 and y. Question number 3. Identify the numerical coefficients of terms in the following expressions. Some expressions are given and we have to identify the coefficients of terms of these expressions. First part is 5 minus 3t square. Now here we have to find the numerical coefficients of terms which are other than which are not the constant terms. Here you can see two terms. The first term is constant 5, and the second term is the term which is containing the variable. So we will write down the coefficient of second term. In this, coefficient of second term is minus 3 into t square. So its coefficient is minus 3. The numerical coefficient is minus 3. In the same way, in its third part, this expression is given x plus 2xy plus 3y. Now in this, all the three terms are non-constant terms. That is, all these three terms contain one or more than one variables. So we will write coefficient of each of the terms in this. Coefficient of first term will be only x is given, which is 1x, so the coefficient will be written as 1. In the same way, coefficient of the second term 2 and the coefficient of third term will be 3y, means the third term is 3y, which means the coefficient is 3. Question number 4, A part. We have to identify the terms which contain x, and then we have to write the coefficient of x. Its first part is y square x plus y. So the term containing x is the variable x is y square x. So we can write the coefficient of x in this. Whatever is getting multiplied with x will be taken as its coefficient. So coefficient of x will be y square. Here we are not asked to find the numerical coefficient. Whatever number or variable is given as a product of that of the variable which is asked here, that will be taken as its coefficient. So coefficient of x will be y square. In the same way, we can find the coefficient of x in this 1 plus x plus xy. Now in this case there are two terms which are containing the variable x. This term is containing x, as well as this third term is also containing x. So the coefficient of x will be written as 1 from the second term and y from the third term. So the coefficient of x will be 1 plus y. Now let us discuss question number 5, 6 and 7 of this exercise. Question number 5 is, we have to classify the given expressions as monomials, binomials and trinomials. The expressions which have only one term, only single term, are known as monomials. The expressions with two terms are known as binomials, and similarly the expressions with three terms are known as the trinomials. Now here the first part of this question, an expression is given with two terms, so this is a binomial. I am writing B for binomial, I'll write M for monomials and T for trinomials. Second part, clearly a single term is given, so this is a monomial. Third part, three terms are given, so this is a trinomial. In the fourth part, a number is given which is a single term, so this is a monomial. Fifth part is trinomial. Sixth part, again binomial, two terms are given. Seventh part, this is again a binomial, two terms are given. 7, m, n, this is a single term. These are not three terms. 7, m and n are getting multiplied, so this is a single term, so this is a monomial. In the same way, ninth part is z square minus 3z plus 8, which is a trinomial, three terms are given. 10th part, a binomial is given. In the same way, 11th part, two terms are given, this is a binomial, and this is clearly a trinomial, the 12th part. Now moving on to the next question, we have to tell whether the given pair of terms are like or unlike. Its first part is 1 and 100. These two terms are given, both are numbers, both are constants, so they are like terms. In the second one, minus 7x and 5 by 2x. You can see in both these terms the variable is only x with single power, so these two terms are like terms again. In the third one, the coefficients are same, minus 29x and minus 29y. The coefficients are same, but the variables are different. So these are unlike terms. We do not consider the coefficients when we are checking for like or unlike terms. We only check their variables, whether they have same power and same variables. In the fourth one, 14xy and 42yx. xy or yx both are same, so these are like terms. Fifth part, 4m square p and 4m p square. Here the variables are same, but their powers are different. In the first term, the power of m is 2, and in the second term, power of m is 1. Similarly, power of p in the first term is 1, and power is 2 in the second term. So these are unlike terms. These are not like terms. And sixth one, you can clearly see these are unlike terms because x and z have different powers in these two terms. Now, seventh question, we have to identify like terms in the following. A few terms are given in this. We have to identify like terms. We will circle the like terms with same color. Minus xy square. This is also. Then yes, only these two terms are like terms. In the same way, let us take a red color for the terms having variables as y into x square. Y into x square. This is also y into x square. X square into y is same as y into x square. So these two are also like terms. Terms containing x square, 8x square and minus 6x square. These two are also the like terms. Terms containing only y, this 7y and this y. These two terms are like terms. In the same way, the terms containing yx or xy, this term and this term, and also there was one term of x square. These three are the like terms of x square. 8x square, minus 11x square and minus 6x square, which are here marked with blue color. And now we are left with the terms which contain single x, x with power 1. This one and this one, these two are like terms. So here we have identified the like terms by choosing different colors.